My name is Kevin Danner. I'm the CEO, founder of Carbon Lock Technologies. We are a Canadian biochar company. We've been at it for about 3 years. My background is in the federal government of Canada, worked on climate policy, worked on carbon pricing, ended up in the Manitoba government as well as a policy advisor to the Premier on how to develop a policy for the province to get to net zero. Got frustrated with the work that I was doing, but also in parallel was bitten by the biochar bug. First heard about it in 2015, Paris Climate Accord. It was touted as a way of reducing all the emissions globally by increasing soil carbon by 0.4%. I bought some, I used it in the garden. My daughter so happened to do her science fair project on it, so we were growing peas in the house with biochar. Interesting. And then I thought, okay, I got a small pyrolyzer, a little kiln in the backyard, started making it. Okay, let's scale this thing. And one of the decisions, there was two decisions, and they're the smartest decisions in the world, probably also the stupidest. The first was, don't buy a system, make a system. So we've designed our own system. It's taken us years. We do now have the Canadian and US patent on that system. But the second decision was, don't do wood waste, do municipal organics. And so that's going to be the topic of my discussion here today. And it is a challenge. I'm sure you've heard that already, and I'm going to go into a few details of that and then some questions. I am going to come at it from the angle of a carbon dioxide removal solution and a biomass availability solution. And then I'll look at some of the challenges and the risks of doing this, but also some of the solutions and strategies moving forward, and then how we plan to scale this across the country and throughout North America. So let's start with this. We all know biochar is a carbon dioxide removal solution, and we're going to need carbon dioxide removal. Okay, that's good. How much are we going to need? So I'm sure you've all seen a graph like this, and it's quite interesting. It sums up, there's where we are, there's where we have to go if we want to get to net zero. You'll never get there by emissions reductions alone, so you're going to have to remove carbon, easy peasy. The problem is, those negative emissions, this whole area here is an entire new sector of the economy. We haven't built it yet. It doesn't exist yet. We have to build that, and there's only so many ways of pulling carbon out of the atmosphere. Fortunately, biochar is leading the pack right now. It is the first out of the gates, and yes, direct air capture will come online, and mineralization is starting to go, and there will have to be messing with the oceans. If we want to get to net zero, we will have to do these things. So biochar is good, but how much can it actually do? I think the IPCC said about 2.6 gigatons would be the maximum that biochar could contribute. It might go up to 6, depending on that. We're going to need 10. Now they're saying maybe 20 gigatons by 2050. And so even if we maxed out all of biochar's potential to remove and sequester carbon, there would still be a ton of removals that we're going to have to do. So if anyone's thinking, well, we're going to run out of removals, if we're going to pursue this and we're going to achieve net zero, we're going to need these. But there's even more than that, and I'll ask a question, see who knows. If we want to go from 430 parts per million down to 330, how many gigatons is that? Does anyone know? Take a guess. It's 800 billion. 800, pretty good, pretty close. 800 billion tons of carbon that's legacy. Even if we stopped right now of all emissions, that's going to have to get pulled down now. And how is it going to get pulled down? Well, it's going to be everything, all cylinders firing, every solution possible, plus a miracle or two. Biochar will play a role here. And biochar will do that by taking biomass and turning it into biochar and sequestering it wherever the heck it can. Now, how much biomass is out there? That is the question, and that is the reason that we decided to look at municipal organics. In total, there's about 8 billion tons of biomass a year available for biochar production. A lot of it's forestry. Difficult to get at sometimes. You saw this morning, perhaps in the session, a lot of that wood is going to go into biofuel. There will be competition from the biofuel industry, and that's good. We need emissions reductions because if you saw from the graph, half of it is reductions, the other half is going to be removals. Agricultural waste, another 2 or 3 gigatons. But the organics that you see in a municipality are about 1 billion plus globally, and this is underappreciated. And this is waste that is on its way to a landfill anyway. And it's going to the landfill because nobody has a use for it. And it's going to a landfill, and the people with that waste are actually paying to get rid of it. So there's an opportunity, but it's also a challenge because it's not easy. We started doing food waste, started the very hardest one. But since then, we've done everything from ag waste, we've done canola stock, we've done biosolid waste, we've done wood waste. Anything that's organic, we've turned into biochar. And we've turned into high quality biochar. We're hitting our H/C ratios of under 0.7 down to 0.4, even less sometimes. And we're working with a number of companies and destinations for this carbon, one of which is Lafarge, recently changed their name to Amorize North America, putting it in concrete. We're working with a number of other horticulture companies that are putting it in floriculture, urban forests, asphalt as well. There are destinations for this carbon. Now, if you look at the different types of it and the different volumes of it, and you say, okay, well, there's lots of waste. It's already going to the landfill. If you can set yourself up at a landfill and say, well, rather than take that truck and drive it over there, drive it over here, and we're going to put it into carbon because we've got these concrete companies that want to buy it or these asphalt companies, then you have something to sell. And there's a sustainability about it as well. This is circular. Carbon in the atmosphere, pulled down by plants, ends up into the economy as food and clothing and wood, and then leaves the economy as waste, goes right past us. There's this carbon ending up in the landfill to go back up. Intercept the carbon. So there's some really good reasons for doing it, and again, and we'll get to that there's challenges to it, but this is how we're scaling, this is how we're trying to build our solution, and how we're going to provide this solution to municipalities that want to turn their waste into value and revenue. This is the US, that's where everybody lives. I'm going to press the next one, it's going to show you where all the landfills are. And do you know where they are? Same place, right? So it's already going there. It's already going. You don't have to go into a forest area. And there are no forest areas in southern Manitoba, I can tell you that. 5 minutes left?
No. 15.
Let me go fast. Okay. How much time do I have?
You go till 11:40.
11:40. Okay, 50. Okay.
No questions then after that.
Okay, that's all right. Very good. That's like so. The strategy is go to where the waste is going, set up where the waste is, set up where the waste pays, and help those that are managing the waste, private or public landfill, turn it into something of value. And this would be the value proposition to a municipality. You have waste, and you have to manage it, and landfills aren't cheap. The very first pilot we did with a small municipality in eastern Manitoba, they just expanded their landfill. It cost them $200,000, which is not a lot, but a very small community. They had to borrow the money. The mayor was really upset. Can we reduce the amount we put in? Well, yes, you can. Take all your grass clippings, is what we did on that pilot, all the grass clippings and leaves, and carbonize it. You've reduced the mass, but you've also diverted from your landfill if you can sell that. And if 40 to 50% of municipal organics, or municipal solid waste is organics, and it is, you're going to be able to reduce that by your landfill by half, extend your life of your landfill by twice as much. That's important in certain regions. I can say in southern Ontario, there's a moratorium on new landfills. Some of those landfills are within 5 years of closing. Some have already closed, and that waste is actually being trucked from southern Ontario to Toronto region to New York State, even all the way to Detroit. To get what a ridiculous thing to do is put your waste on a truck and burn diesel and take it on a 4-hour drive down a highway into another country. Okay? Waste reduction, get your landfill smaller, save some money on those maintenance costs. You can also use the carbon in the landfill. Start a new cell, we're going to line it with biocarbon. This helps with leachate. You can also use that carbon to filter the leachate as you pump it out, or filter your wastewater. And we are working with the University of Manitoba on a really interesting project, filtering wastewater and leachate. Results so far are really interesting. There's health benefits, there's environmental benefits. The smell of a landfill. Methane doesn't smell, but organic waste decomposing smells. And who's smelled a landfill? Yeah, doesn't smell good. So eliminate the odor problem, eliminate the scavenger problem, turn it into biocarbon, and if you just dump it in the landfill, nothing's going to eat it. So you've got a number of solutions that you're hitting here. The methane issue. Methane is from decomposing waste, and it's 25% of the, in Canada, and I'm sure it's the same in the United States, 25% of the methane comes from landfills, sitting there with no economic value to it. And in Canada, regulations are coming, they're working on them right now, they're going to tax that methane. And so if you're a municipality, there's a risk there. How am I going to avoid the methane tax? How can I keep the odor down for the community? How can I keep costs down? Carbonization and biochar. And then there's the policy leadership, the policy alignment. You're the leader, you're the first out of the gate. Other municipalities come and see what you're doing. You have the opportunity to meet state and federal targets for emissions reductions. You have the opportunity to be the very first net zero community in North America or the world. And again, we're going to get to net zero? Sure, what does that mean? Everybody? No, someone's got to be first, and it's going to be a town that's first. I think it's going to be a town that's first, and then a community, and then a city, then maybe a state or province, and maybe a country. So there's so many potential benefits, and if you structure this right, in partnership with a company, you can turn your waste into value and generate revenues doing that. What are the challenges? I'm going to need a sip of water for this one. Thank you. It is not easy. Oh, here comes a big load of watermelons. Have fun all day long trying to turn watermelons into biochar. Short answer, you can't. Here comes some pallets. I've thrown hundreds of pallets into a wood chipper. It comes out as chips, right? But also comes out as a whole bunch of nails. That's a difficult feedstock. Biosolids. I've stood on a frozen lagoon with an ice fishing auger getting biosolids. It's really stinky stuff, and it's really hard. And guess what? It's really wet. So the feedstock variability and quality, it's a massive challenge. And how stupid to think that you can go ahead and do it? Well, we are. The infrastructure, logistics, you're setting up at a landfill. There's a weigh scale. Trucks are coming in. Where's that truck going to go? What's in that truck? How are you going to go upstream to the waste suppliers that's coming from a grocery store? How does that get there? There's a green bin program for the community. Open it up. It's full of diapers and dog shit. Sorry. There's some real difficult challenge in just trying to set up a processing plant that's going to be able to take all of these different types of forms of carbon and turn it into biocarbon for sequestration and carbon credit generation. Time. Good. Public support. We've heard of Saratoga. Anyone? Okay, so yes, of course. It's 3 years they worked on that project in New York State to try and get a biochar facility in. Public didn't want it. They just pulled out just this last year. That's sad to see. That was hard. See, I'm sure that was hard for that company. You have to be able to get the community on board. And then financing in markets. This is heavy CapEx, like any big biochar facility. You've got to invest a lot of money up front in the equipment. If you're going to take wood waste, you need a wood chipper. If you're going to take baled stock, you need a bale grinder. You need a tub grinder. You need a pelletizer. You need all this equipment, and then you need storage, and then you need a reactor system, and then you've got to go all downstream. And who's going to buy this carbon, and the markets that are there. I'm sure right now there are piles and bags of biochar sitting on biochar companies' lots in totes, maybe not going anywhere. It's going to be really difficult to build the markets out for all these things. Difficult, but we can do it, and we are doing it. So some solutions. The solutions to the variability of the feedstock, blending. You won't always just get tomatoes. There's a lot of wood waste, there's a lot of grass clippings, there's a lot of leaves and branches. In Minneapolis, it's the emerald ash borer. For us in Winnipeg, it's the Dutch elm disease. So many trees coming down. There's a lot of wood. That chipped up, mixed in with some food waste, mixed in with some lawn clippings, mixed in with some other different types of organic waste that come in, and then densified into a pellet, you've got a really nice consistent feedstock that carbonizes very well in our reactor system. Manage that moisture, use as much energy as you can to keep the feedstock dry, densify, you have something. It is all mixed up in there, so there's a question of the quality after it comes out. Okay, well, you've got a biochar pellet now. Well, how do you know that that pellet's the same as that pellet? Was this one a pellet from watermelon and this one from wood? What's the H over C? What's the chemistry of this? What we're finding, if you blend it significantly, it doesn't make that much of a difference. There is a little chemistry different, but in the applications we're using, that doesn't matter so much. And the H over C is consistent. Is it heavy on pre-processing? Is there heavy costs up front? Do you have to reintegrate as much energy as you can into that process? Yes, you do. But again, that doesn't mean don't do it, because there's a real upside here. The integrated operations, looking forward, again, set up at every landfill that you could. Set up beside an anaerobic digester. They have digestate. Set up close to the concrete mixing plant, because then they're going to take the carbon and they're going to put it in their concrete. You recall the map of all the population centers and all the landfills? You could do another one. Where's all the concrete being poured? A lot of it is in those spaces. Where's a lot of the asphalt? In those spaces. Where are a lot of industries that can use carbon? In those spaces. So focus, which we are focusing on those end uses that are close to the urban centers where the waste is already going and turned into the carbon. And partnerships. We have someone here, the economic development officer from a municipality in Winnipeg, just south of Winnipeg. We're working with them to set up our system at the municipal landfill and work in partnership with them under a triple P program so that we can share the risk and share the revenue with the municipality. I don't know that I would want to do this by setting up, owning my own piece of land, setting up my own factory, putting up a sign saying, bring your waste here. You have to work in partnership with municipalities. 5 minutes. Now it's really 5 minutes, which is good, because that's the last slide. Next steps. So yes, the rural municipality of Rochot is just south of Winnipeg in Manitoba. An excellent municipality to work with because it's not Winnipeg. Is anyone here from Winnipeg? No. It's not Winnipeg. A municipality that's very active. They've already set up a food waste program. They've already electrified a lot of their truck fleet, very progressive-minded in where they want to go with this, but also so close to a center that has 800,000 people that they can take waste from that municipality. It's ideal. So that's the group that we're working with on this first demonstration facility. We are in the planning stages of this. This will be, once it's completed, will be a $5 to $10 million processing plant that we will be able to produce up to 2,000 to 3,000 tons of biochar a year. We're going to work our way into that, and we're going to work our way into that with some of the easier feedstocks, and then start to introduce and blend in some of the more difficult ones. We've also identified in that community some of the feedstocks that they want to take, but also some of the feedstocks that they've rejected because they don't want it in their landfill, because it's bulky, that it's organic, and that smells bad. And that stuff, well, that goes to Winnipeg. But once we are able to set up the facility and take that, then this becomes a revenue stream across the waste scale. And we're working with Lafarge on the back end, and they have a processing plant within 30 miles. There's enough there, capacity there to take almost all of the stock that's going out of that. So we're working very hard on that partnership with the back end user. We're working very hard with the municipality on the front end, and then work on the carbon credit offtake over top of it. There's 3 revenue streams there. That's plenty for our company and the municipality to put this in place. And then to scale this up, other municipalities come through, let's take a look at this, and back to the value proposition. How would you like to take your waste and turn it into value? How would you like to intercept that carbon as it's going past you into the landfill and turn it into something valuable for other processes, and then sell the carbon credit on top? It is not easy. It's taking everything we've got to do it, but we're making progress, and this is where we're going to go. And thank you for your time. Questions?